Today's lesson is on graphs of linear equations. It's lesson 4.3. So a linear equation is an equation whose graph is a straight line. So when you graph it, it'll form some form of a straight line, whether it's diagonal, horizontal, vertical. And the solutions to an equation are all coordinates on the graph line. So here's our equation. We put in some random values for x, trying to keep them as values that didn't make our graph too big, so we kept our numbers low. We substitute our values in our original equation here, and then as a result, we obtained y values. And that gave us coordinates that we could actually plot on our graph over here. So -2, 1 is here, -1, 2 is here. 0, 3 would be about right there. 1, 4 here. And you'll notice that as we graph those points, they're creating a straight line. So that's why we call that a linear equation. So we're going to start with this equation. There's a few steps you want to kind of solve when you do these. Step 1 is make sure that the y is all by itself. So in this case here, y is over there with -1. So we're going to add 1 to both sides. So we have y equals 2x plus 1. And then we're going to put that right in here. And then we're going to come up with input values for x so that we can find a y. And then eventually we're going to put all of these on the graph. So I don't want my values to get too big, so I'm going to use 0 for one of them. 0 is always an easy one to use. And then I'm going to use 1 and then maybe -1. So I'm going to plug those into my equation. I'll put 1 in for x. Well, that means 2 plus 1, so my y value should be 3. If I put in 0 for x, that's 0 plus 1 or 1. And if I put -1 in for x, I get -2 plus 1, which is -1. And then I'm going to graph these three ordered pairs and hope that they make a straight line. Okay, so our first ordered pair here, 1, 3, would sit about right here. 0, 1 would be about right here, and then -1 about right here. And then we're going to connect those three. So we know it's a linear equation because it connects to form a straight line. All right. So let's go ahead and do this one with 5x because you really have to be careful on what kind of values you put in there for your x. So I'm going to use 0 again. Since I'm multiplying by 5, I want to keep my numbers small because the values on my graph could get large quite fast. So I'm going to use a 1 and then also a -1. So 5 times 1 is 5. 5 times 0 is 0. 5 times -1 is -5. And then I'm going to graph those ordered pairs. So my first one right here is when x is 1, y is 5. Should sit about right here. 0, 0 would be at our origin. And then -1, 5 would be about right here. I didn't leave myself very much room to do this. So my graph would look like that. Okay. So we're going to move on to one of these where we have x equals 3. Well, when x equals 3 in a linear equation, we know that all values for x have to be 3. So I'm going to put that in about 3 times. And I know x equals 3 should make a vertical line that cuts through the x-axis at 3. So I'm going to maybe try 2, a 0, and a -2 here. So this is my equation. I really don't have anything to solve. I just know that whatever ordered pair I have, x has to be 3. So if I go here and graph my first ordered pair at 3, 2, sit there, 3, 0 would be about right here, and then 3, -2. And that's exactly what I need to create, is a vertical line that cuts through the x-axis at 3. So on the opposite end of that, if y equals -5, I'm going to fill in -5 as the y value for each of my ordered pairs. And I'm going to do the same thing again. I'm just going to use those same values, 2, 0, -2. So I have something to graph with -5. So 2, -5 would be about right here. And then I have 0, -5. And then I have -2, -5. As should happen, I create a horizontal line which goes through, cuts through the y-axis at -5. All right, so let's go ahead and do a few of these. I'm going to go, actually, we might just do one of these. So let's go to this one right here. Now, y is already by itself, so that's good. So I can fill in my equation right here. So in for x, I'm going to go ahead and use 0, maybe a 1, maybe a -1. So I got -2 times 1. -2 plus 1 is -1. And then -2 times 0. So that'd be 0 plus 1 or 1. And then -1 in for x. So that becomes 2 plus 1 or 3. So I'm going to graph those. 1, -1 would be here. 0, 1 would be about right here. And then -1, 3 would be about right here. And once again, I am creating, oops, I put this one up a little bit too high. It should be about right there. I am creating a diagonal line again, so that proves to me that that's a linear equation. So let's go ahead and try some that have a fraction. Let's try the second one here. So I'm still going to put this in here, and again, always make sure that y is by itself before you input your equation. And when I have a fraction, I don't want to make this too difficult because it's a fraction, so I want to try to figure out a way to get rid of my denominator, then I won't have a fraction. So my first input for x is almost always going to be 0. And then I'm going to look at this denominator up here, and I'm going to use that number, and then I'm going to use the opposite of that. So I'm going to use the -4. And I think you'll see why when we start this. 3/4 times x is 4. Now my 4's are going to wipe out. So now I have 3/1 or 3 plus 2, which is 5. Now if I put in 0, well, 3/4 times 0 is just 0, so I'm going to put 0 there. So I end up with 2. That's why we like 0. Then I'm going to go ahead and put -4 in for x here. I'm going to add 2. So like before, my 4's are going to cancel out. So that's 1 and 1. So I have -3/1, which is -3 plus 2, which is -1. I'm going to go ahead and graph those. So at 4, 5, at 0, 2, and at -4, -1. And they connect together pretty nicely right there. So that's what that looks like when you have fractions. You'll use 0, whatever the denominator is, and then it's opposite. Okay, so these are problems where we definitely need to get y by itself. I'm going to go ahead and do this one on the end. So I'm first of all going to get rid of my x to start getting y by itself. So now I have 2y is 8 plus x. So to get rid of 2, I'm going to divide by 2. So we end up with y equals 8 divided by 2, 8 divided by 2 is 4. Plus we have x over 2. We could also call that 1/2 x. So we've divided everything by 2. Now I'm just going to erase what I wrote over up here so that I can actually put that in my chart. So I'm going to flip-flop this, and you'll see why later on next week, why I want to try to start putting my x term first. So it's a good habit to get into. So this is my new version of that same equation. So again, we have a fraction, so I'm going to use 0. My denominator here is 2, so I'm going to use 2, and I'm going to use negative 2. So 1/2 times 2, well, a number times its reciprocal is always 1, so 1 plus 4 is 5. 1/2 times 0 is 0, plus 4, which is 4. And then if I take 1/2 times negative 2, I get negative 1 over 1, which is negative 1, plus 4, and that will give me 3. So I'm going to graph those. I have 2, 5, which would be here, 0, 4 would be here, and then negative 2, 3 would be about right. Oops, about right here. So then I can, well, that is not supposed to be there, and my graph will look just like that. Okay, we're going to go ahead and stop there. Hopefully this makes a lot more sense.